take a look at our popular triangles and see what they would look like inside of the unit circle. So if I start with my 45, 45, 90 triangle, we have our right angle, and the other two angles are 45 degrees. Okay, so this is an isosceles triangle, which means that the two sides opposite 45 degrees will be the same, and we've called that 1. So then using Pythagorean theorem, the hypotenuse is the square root of 2. With the 30, 60, 90 triangle, we put the 60-degree angle at the bottom. Okay, none of the sides are going to be the same, so what we've done in the past is just reflected this triangle over itself so that it becomes equilateral, so 60, 60, and 60. So then that bottom side we called 2, so half of that would be 1, which means the hypotenuse is also 2. And then using Pythagorean theorem, other side is square root of 3. So what we're going to do is take these triangles and put them inside of the unit circle, which means that the radius needs to be 1. So these hypotenuses need to become a 1. So what we're going to do is just shrink them a little bit. For the first triangle, we're going to divide all the sides by the square root of 2. Here's the square root of 2 divided by square root of 2 is now going to be my radius of 1. 1 over square root of 2 is just square root of 2 over 2. Okay, so this is just a shrunken version of the original, but the ratio of the sides would stay the same. Let's look at the second one. Do the same thing. This time I'll divide all the sides by 2. So 2 divided by 2 is 1. Square root of 3 over 2. And 1/2. Okay, so let's look at the first quadrant of the unit circle using these two triangles. Okay, so let me start with the 45 degrees. Okay, again, remember that this radius is 1. So at the far right, this would be the ordered pair 1, 0. At the top, it would be 0, 1. Okay, so this is representing our 90 degrees, so then half of that's going to be 45 degrees. Okay, looking back at our triangle, we should remember that the sine of 45 degrees was 1 over the square root of 2 over 2, or now as we can see it's square root of 2 over 2. So that means that the sine and cosine are related back to the x and the y values. So the sine of 45 degrees was opposite over hypotenuse, so this is really just going to be the y coordinate divided by 1, or in other words, just y. Okay, same thing with the cosine of 45 degrees. It's going to be the adjacent over hypotenuse, so that's going to be the x coordinate over 1, or just x. So that means on the unit circle, the x coordinate is going to be cosine, the y coordinate is going to be sine. So let me actually write that at the top here. So the first coordinate is going to be cosine of the angle, and the second coordinate will be sine of the angle. So at 45 degrees, cosine and sine are the same, which are square root of 2 over 2, square root of 2 over 2. Okay, again, this was 45 degrees. At 30 and 60 degrees, so going a third of the way, and then 2/3 of the way. Again, the first coordinate is cosine, the second coordinate is going to be sine. So looking at our triangle here, 30 degrees, cosine is going to be square root of 3 over 2 over 1, and then sine is going to be 1/2. So then because we have cofunctions and complementary angles, the cosine and sine are just going to switch for 60 degrees. Okay, so that's the first quadrant of the unit circle.